Now we're going to look at an example of a piecewise function. Piecewise function is just a function that's put together with a bunch of little pieces. So we have one piece here, y equals negative x plus 2. And we know that's going to be a line. We have y equals x squared. That's going to be a parabola. And we've got y equals 1. We know that's going to be a horizontal line. And so we call this a piecewise function because it's pieced together. And instead of graphing it on the whole domain of all x's, we're going to graph it on just a limited domain. And we'll see how that works right now. So, we have our graph over here. We've got our x-axis, y-axis. Let's label it. We're going to go out to 10, out to 10. All right. So, let's start by looking at this first graph, y equals negative x plus 2, and we're going to graph this. We're going to graph this to start on the whole axes. All right, so y equals negative x plus 2. We've got a y-intercept of 2 and a slope of negative 1. So it's going to be going down like this. So we're up to the left, something like that. Okay. And so we get this graph right here. Let's try that line again. So we have a line something like that. That's how we would graph it normally. However, we're going to limit the domain to all the x's that are less than or equal to negative 2. So negative 2 is right here. Our axis, negative 2. Okay, and so we're going to just erase, let's get out the eraser, we're going to erase everything up to, too far, negative 2. Alright, and now notice that negative 2 is included because of our or equals 2. So at that point, negative 2, we have the point 4. Y is 4. Because you'll notice when you plug in negative 2 here, negative 2 plus 2 is 4. The y value is 4. That's what we have right here. All right. So we got that one. And now we're going to look at our next function. We have y equals x squared. And we have, well, let's think about this graph on any domain. So we have y equals x squared. Y equals x squared. All right, and so we know that that has a vertex at 0, 0. 1 squared is 1, 2 squared is 4, and we reflect it across, and it looks like this. And it goes on forever up here. All right. Now, that would be if we had all real numbers for our domain, but we are restricting our domain here from negative 2 to 2. Now we notice that this side is included, so we're going to include positive 2, but this side's not. So we're going to back this up here, and we're just going to graph it now to when x is negative 2. And at x is negative 2, we're going to put an open dot. Now we have an open dot there, but we notice that that happens to be the same point right here as it was for this line. That's not always the case, as we'll see here in a moment, but that works nice there. And over here, we're going to just cut this down. Let's see if this will cooperate. Okay. And here we go. All right. We notice that this one is included, so there's going to be a solid dot here because of this or equals 2 here. Last but not least, we have y equals 1. So let's graph y equals 1. And we'll say y equals 1. Let's get a different color here. And that's just a horizontal line right at y equals 1. all these guys here. And this is going to be for all x values that's greater than or equal to 2. So this line just starts when x is 2. So we're going to put a little hollow dot there, or open dot. I'm going to graph it to the right. So there's the line, y equals 1 for x is greater than negative 2, but we cut it off here. All right, so this thing pieced all together is our piecewise function. And that is how we graph a piecewise function.
Made with DoodleCast Pro.